All right, Algebra 2 fans, today we're going to look at synthetic division, okay? With synthetic division, I'm just going to show you it's an appreciation to long division, okay? So remember, yesterday when we did long division, remember all this work that we had to do, all this multiplication, and then the division and all that? So there's a lot of work here, okay? With synthetic division, it's very, very short and easy, okay? So let's look at it. So synthetic division uses coefficients and the constants. So coefficients, remember the coefficients are the numbers in front of x's, so there's a 1 there. There's a 2, a -3, and a 5. Remember, you got to say the signs. So we have a 1, a 2, a -3, and then the 5 is a constant. Okay? So those are the coefficients. So we're going to write down 1, 2, -3, and 5. Give yourself a little spacing in there. They don't squeeze everything together. And then we use this little, I don't know, whatever you want to call it. A little left-angled symbol, whatever you want to call it. Okay, now, the number that we use, okay, this is what I wrote here, possible root. X minus 3 is the possible factor, okay, what it becomes the possible root. So x minus 3 is the possible factor. The possible root then, think about this as a factor, then the root becomes 3. Okay? Remember, if x minus 3 is a factor, remember you set it equal to 0. That's how we do our factoring. Okay? So that means I put a 3 right here. Now, everything that we do is multiplication and addition. Okay? So we start the process by dropping the lead term. So I take this lead term, this 1, and I bring it down. Okay? And now everything else is just multiply and add. So we start saying 3 times this 1 right here. 3 times 1 is 3, and the result goes here. Okay. And now I add these two up. And then we start over. 3 times this 5, that's 15. That's where the result goes. And then I add. Okay. Then it's 3 times the 12 is 36. And then we add. I put a little line there. You'll see in a second why I do that. Okay, this line right here, this 41, this line right here represents the spot for the remainder. So there's your remainder. This is how many terms? There's 3 terms here. So this is our quadratic now. This is a second degree equation. Or a second degree expression. This is a third degree expression. 1, 2, 3, 4 terms. This is a second degree. We write this out. These are your coefficients now. So this is the x squared, so 1x squared. That's right, we don't need the 1 in front. Then it's positive 5, so plus 5x. And then it's plus 12. And we have a remainder of 41. And like yesterday when we wrote out our remainders, we have to do plus, and then we're going to do 41 over our x minus 3. Wasn't that a lot faster and easier? So you're probably saying, Mr. Prada, how come we didn't do that yesterday? Well, you have to understand long division first. Okay? So notice we had the exact same factors, x squared plus 5x plus 12. We did the exact same problem. And then there's your result. There it is right there. There's the 1, the 5, the 12. There's the 1, the 5, the 12. Okay? All right. Let's look at another one. And so I'm just going to, in the notes, so I'm going to go grab my other problem that we did. So I don't need a lot of room now. So we have x to the fourth minus 2x minus 5 divided by x plus 3. Okay? And now we're doing the same thing. We're going to do synthetic division. Remember yesterday when we did this, we needed placeholders. Okay? We did all of this work. We needed placeholders. Well, guess what? We still need placeholders. When we're doing synthetic division, long division, we still need placeholders. That's right. So I'm missing which terms? That's right. A fourth degree is supposed to have 5 terms. Count them. 1, 2, 3, 4, 5. So 4, we're supposed to see an x cubed, so we're missing an x cubed. So x to the power of 3, so 0x to the third. And then we're also supposed to see a square. So 0x squared. Okay? So let's set this up. So our coefficients then, remember there's a 1 in front here. If you need to see it, put it in for yourself. So our coefficients are a 1, a 0, a 0, a negative 2, and a negative 5. So let me get those written down. So we have a 1, a 0, a 0, a negative 2, and a negative 5. Here's your little lefty angle thingy, whatever you want to call it. And now this is the possible factor. That's what we're dividing by. So what do we use? That's right, we're using the possible root, which is, that's right, in this case it's a negative 3. So right here I'm going to put negative 3. Okay. Then we'll put our line under here. Make sure you have enough room so you can squeeze in the numbers just like we did before. That's right, we dropped the lead term. So I dropped the 1. All right, now we start the process. Negative 3 times 1 is negative 3. Then we add. Start it again. Negative 3 times negative 3 is positive 9. Then we add. Negative 3 times positive 9, negative 27, and we add. Then negative 3 times negative 29 was 87, positive, and then we add. And that gives us 82. This last spot, that's right, that's the remainder. So this is a fourth degree. We do our long division. This becomes a third degree. There's 4 terms. This is a third degree, so this is x cubed. Now, if you're not sure, you know what? Start on this end here and say 0, 1, 2, 3. Those are your exponents. So 1x cubed minus 3x squared plus 9x minus 29. And then 82 is positive, so plus 82 over your x plus 3. You just did synthetic division. Okay? A lot easier than what we did yesterday. All right, we got one more to do. All right, last one. So we have 2x cubed plus x squared minus 15x minus 20 divided by 2x plus 3. All right. So everything's the same way. We're going to do our synthetic division. That's right. Here's your coefficients. There's the 2, right? There's a 1, negative 15, negative 20. We're not missing any terms here. That's a third degree equation. We're not missing any terms. Okay, so 2, 1, negative 15, negative 20. Here's your little left angle thingy. And now I need the possible root. All right, if you don't know this, we'll work it out. 2x plus 3 equals 0, because that's how we figure out the root. So I'll subtract 3, and then I'll divide by 2. So we have x equals negative 3 over 2. Oh no, Mr. Parada, you gave us a fraction. Wah! Fractions are friends. All right, processes start the same. What do? That's right, we drop the lead. All right, in your handy-dandy calculator in your brain, negative 3 over 2 times 2, we get negative 3. How did I know that? Well, I just say to myself, 2 goes into 2 once times negative 3. Negative 3. Now I add. So that's negative 2. All right, doing it again. 2 goes into negative 2, negative 1 times negative 3 is a positive 3. And then we add. Okay. Do it again. Negative 3 over 2 times negative 12. That's right, it should give us an 18. And then we add. Okay? Then we're going to add, so we get negative 2. So there's your remainder. Okay? Now the only thing with the synthetic division, what we need to do is right here. You see all these 2's and 12's? That's right, I need to divide each of these by 2. So we have our official part. Okay, we don't divide this one by 2. We only divide this by 2. Unfortunately, that's just what we have to do. So now I have x, and that happens every time with a fraction. So now I have x squared minus 1x minus 6, and then it's minus 2 over 2x plus 3. And this actually happens because of the fraction, okay? Because we had it ended up doing the fraction, it makes this happen, okay? And remember we did all that yesterday? When we did all this? There it was, x squared minus x minus 6 minus 2 over 2x plus 3. We have the exact same piece. Folks, that's synthetic division. Your homework is to do the problems from the yesterday, but instead of doing long division on every single one of those problems, I think there was 5 altogether, you're going to use synthetic division. All right, and then make sure you write out your answers in this fashion, okay? And then don't forget, if we have no remainder, that means we have a factor, okay? That means we have a factor. All righty. We're all done.